Welcome to the Severe Weather Spotter training produced by the National Weather Service in Missoula, Montana. The first video in this series is the importance of the spotter. So why are spotters important to the National Weather Service? The information we collect help us produce better forecasts, verify and supplement our radar and satellite data. Bottom line, get us ground truth. As this picture shows, one spotter could be easily reporting sunshine while the other one is receiving heavy snow. How can you help as being a spotter? First off, you allow us to call you when we think that there is weather in your area, but most importantly, that you give us a call when you're experiencing significant weather. Our technology is great, but it does have its limitations and we need the ground truth. Our greatest piece of technology is our Doppler radar, which sees most of the northern Rockies, from Eureka, Montana to Leadore, Idaho, from Butte, Montana over to Grangeville, Idaho. We get new weather information every 6 minutes. It can sample the winds in the upper atmosphere down to the surface. It can also give us precipitation amounts and hail sizes. The latest upgrade to the radar now allows us to determine the precipitation type between rain, snow, and hail. But the biggest limitation is that our radar sits on top of Point 6 Mountain, which is at 8,000 feet. The lowest elevation slice that our radar can produce is a half a degree. When you take a half a degree radar beam and push it all the way out to Kalispell, we are only seeing about 15,000 feet above the ground. So that's quite a bit of atmosphere that is not actually being detected by our radar. Another piece of technology that the National Weather Service uses is the geostationary satellite, which provides us with a visible image which can only be used during the day, an infrared image which senses the cloud top temperatures, water vapor, an estimation of the amount of moisture in the atmosphere, and a fog product. As this picture indicates, the best resolution we can get is 1 kilometer by 1 kilometer, which is nowhere close to what Google Maps provides. Also, we only get an updated image about every 15 minutes, but the weather can change dramatically in that amount of time. The National Weather Service has 122 offices across the country, including its territories. It is staffed by 2 forecasters 24 hours a day, 7 days a week, all year long. The forecasters have numerous computer models and surface observations, radar, satellite, and web cameras to help us produce forecasts. But as this picture depicts, we only have one small window that is looking to the south, and we see it in a valley. So it's very hard to actually see what is going on all the way around us. So that's why we continue to need ground truth from our spotters. The National Weather Service issues a slew of watches, advisories, and warnings. Watches indicate conditions may be favorable for severe weather in or near your area. Advisories means significant weather is about to occur, but it's predominantly a nuisance, and as long as you use common sense, should not be a threat. While a warning is severe weather is imminent or occurring in your warning area, and you should take necessary actions. But the definitions for each of our advisories, watches, and warnings are very different, especially during the time of year and the type of weather, but also the impact that the weather is going to have on society. So what do we classify to be significant weather? Let's start with hail. We need a thunderstorm with a strong updraft, which will lift moisture high into the atmosphere, causing it to freeze. That ice will fall back down below freezing, collect moisture, get caught back up into the updraft, and be relifted to form ice. This can actually happen several times. Once the hailstone is too heavy for the updraft, it will fall to the ground. As this picture depicts of the Coffeyville hailstone, you can see the multiple layers that were created from this process. The largest hailstone fell in Vivian, South Dakota on July 23, 2010. It was 8 inches across, weighed 1.92 pounds. Hail causes more than $1 billion in property and crop damage each year across the United States. Thunderstorms need strong updrafts in the freezing layer to produce large hail. Large stones can fall to the ground greater than 100 miles per hour. The following are a few images of hailstones that occurred across the Northern Rockies. Strong winds can be created by either microbursts or the downdrafts of thunderstorms. Downdrafts allow strong mid-level winds to be mixed down to the surface, while microbursts are straight down winds that hit the ground and spread out in all directions. These winds can be severe and cause significant damage. Also, these types of winds can cause erratic fire behavior. The following are pictures of microburst and straight line wind damage across the Northern Rockies. A thunderstorm with extreme straight line winds moved over the Mission Valleys and on to Flathead Lake, causing boats to be tossed up onto shore, collapsing barns, and toppling large trees. A microburst went over the Libby area, which took out the drive-in movie theater. River flooding is another concern for the Northern Rockies, especially November through June. During the winter months, we can actually have a warm air mass move over the area, causing snow to melt with moderate to heavy rain, producing rivers to swell and flood. Also in the winter, we can have an Arctic air mass set over the region, causing ice jams in the rivers. But the peak actually hits in May and June, when we are gaining the natural melting of snow with our spring and early summer rain showers, causing our rivers to reach flood stage. Also in spring and early summer, the ground can become saturated by melting snow, and with steady rain, landslides can become problematic. This picture is of a landslide in Lemhi County, while this one occurred near Orofino, Idaho. The Northern Rockies do get tornadoes, about one every 3 years. The typical type is the non-supercell tornado, which is formed by eddies along a surface boundary being pulled vertically by a passing shower or thunderstorm. Here's a picture of a tornado north of Kalispell formed along a weak Arctic boundary. You can actually see a second tornado in the far background. The Northern Rockies do get supercell tornadoes, but those are few and far between. So which snow event actually has a bigger impact on you? The Northern Rockies should expect light snow from time to time, but heavy snow events can cause road conditions to change quite rapidly. Freezing rain is actually fairly common around the Northern Rockies during the winter months. When valley inversions set up with temperatures well below freezing and a warm air mass moves over the area, we can actually get freezing rain to develop. Generally, the valleys will mix out quite quickly, but with the multitude of valleys across the Northern Rockies, we are bound to get isolated events. Freezing rain on road surfaces can cause a very serious driving conditions. Dense fog is also common in the Northern Rockies during the winter months. Dense fog can cause visibilities to change rapidly. Also, with temperatures below freezing, dense fog can actually form icy conditions on roadways. Here is a list of criteria the National Weather Service in Missoula is looking for: tornado, funnel cloud or waterspout, high wind estimated or measured above 40 miles per hour, heavy rain of a half an inch or more per hour, flooding of any kind, hail a quarter inch or larger, visibilities reduced to less than a quarter mile, heavy snow 1 inch or more per hour, weather-related damages or injuries. The 1-800 number provided on this slide is for reporting weather, not receiving a forecast. The 1-800 number allows you to either leave a message or talk to a forecaster. When leaving a message, please state your first and last name, the closest town that you're to, what you're reporting, and the time the weather was experienced and how long it lasted. If you're actually talking to a forecaster, they may have more questions for you. For up-to-date weather, either go to our website or follow us on Twitter and Facebook. Thank you for watching the video on the importance of the spotter. The next video in this series will be thunderstorm ingredients.